Hello. Hello and welcome to this video. This is the 44th set of problems on theory of equations and polynomials. That is, we will solve problem number 431 to 440. So I will say, which I say in every video, that when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then you should look at the solution. The link to download this PDF will be in description, and at the end of the video, I'll show you how you can download it. So without further ado, let's get started. Question 431 says that if alpha beta are the roots of the equation x square minus px plus q is equal to 0, then find the quadratic equation, the roots of which are alpha square minus beta square into alpha cube minus beta cube and alpha cube beta square plus alpha square beta cube. So we are given that alpha beta are roots of the equation x square minus px plus q is equal to 0. So alpha plus beta will become p and alpha beta will be q. Now we look at the one root of which we have to form the quadratic equation, which is alpha square minus beta square into alpha cube minus beta cube. We take alpha minus beta common from both of them. It becomes alpha minus beta whole square. And from this term, the remainder would be alpha plus beta, or rather the quotient will be alpha plus beta. And from this, it would be alpha square plus beta square plus alpha beta. Now, this alpha minus beta whole square can be written as alpha plus beta whole square minus 4 alpha beta, which is p square minus 4q. This alpha plus beta will be p, and alpha square plus beta square plus alpha beta can be written as p square plus q. And the other root would be alpha cube beta cube plus alpha square beta cube. So we take alpha square beta square common and we have alpha plus beta. So in this case, the values when we substitute is p plus q square. There might be some mistake here. So if you take alpha minus beta common here from, then it becomes alpha square plus beta square plus alpha beta. That is equal to alpha plus beta whole square minus alpha beta. So there should be a minus sign here, p square minus q. Okay, so that is a mistake. Now once we have these two, we can represent this as x square minus p. P comes from here, and then p square minus 4q into p square plus q. So we add these two stuff, okay, and then take p common. So p square minus 4q from here and p square plus q from here and q square from here. And the constant term would be multiplication of those. So p into p square, q square, and then remaining of that. So that's how we find the quadratic equation. Question 432 says that if alpha beta are the roots of the equation x square minus bx plus c is equal to 0, then find the quadratic equation, the roots of which are alpha square plus beta square and alpha cube plus into alpha cube plus beta cube, and alpha to the power 5 beta cube plus alpha cube beta 5 minus 2 alpha to the power 4 beta to the power 4. So from the given equation, we have alpha plus beta is equal to b and alpha beta is equal to c. Now there should be a beta here. It's a typing mistake. So we have alpha square plus beta square and alpha cube plus beta cube. We can write this as alpha plus beta whole square minus 2 alpha beta into alpha plus beta cube minus 3 alpha beta into alpha plus beta. So this becomes b square minus 2c, and this becomes b cube minus 3c and b. The other root is alpha to the power 5 beta cube plus alpha cube beta to the power 5 minus 2 alpha to the power 4 beta to the power 4. We take alpha cube beta cube common, we are left with alpha square plus beta square minus 2 alpha beta. So this we can write as c cube into b square minus 4c. And once we have that, we can have the quadratic equation as x square minus b square minus 2c, that is this term, into b cube minus 3bc plus c cube into b square minus 4c into x. And then we write the product of these two quantities, which is the constant term. Question 433 says that if the sum of the roots of the quadratic equation x square plus bx plus c is equal to 0 is equal to the sum of squares of the reciprocals, then show that b square by ac plus bc by a square is equal to 2. So we let alpha beta to be the root, then alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. Now from the question, the sum of roots is equal to squares of reciprocals, that is 1 by alpha square plus 1 by beta square. Once we have that, we substitute the values minus b by a, and the right hand side becomes alpha plus beta whole square minus 2 alpha beta by alpha square beta square. That is minus b by a is equal to b square by a square by c square by a square minus 2 into 1 by c by a. Once we have that, we simplify and we get the required equation. Question 434 says that the time of oscillation of a rigid body about a horizontal axis at a distance h from the center of gravity is given by t is equal to 2 pi square root of h square plus k square by gh, where k is a constant and g is acceleration due to gravity. Show that there are two values of h for a given value of t. If h1 and h2 are two values of h, show that h1 plus h2 is equal to gt square by 4 pi square and h1 h2 is equal to k square. So we are given this equation, t is equal to 2 pi into square root of h square plus k square by gh. We square, so this becomes t square and gh is multiplied divided by 4 pi square, which is equal to h square plus k square. Now we bring everything to one side and write a quadratic equation in h. So that becomes h square minus t square into gh by 4 pi square plus k square is equal to 0. Since it is a quadratic equation, there will be two possible roots, h1 and h2. And sum of roots will be given by minus of this term, that is t square g by 4 pi square, and h1 h2 would be k square. Straightforward problem. Question 435 says that if alpha 1 and alpha 2 be the roots of the equation x square plus px plus q is equal to 0, and beta 1 beta 2 be the roots of the equation x square plus rx plus s is equal to 0, and the system of equations alpha 1 y plus alpha 2 z is equal to 0, and beta 1 y plus beta 2 z is equal to 0 has non-trivial solutions, then show that p square by r square is equal to q by s. So here we have alpha 1 plus alpha 2 is equal to minus p, alpha 1 alpha 2 is equal to q, beta 1 plus beta 2 is equal to minus r, and beta 1 beta 2 is equal to s. Now the two equations which we have, that is these two equations, we solve those equations by elimination. We get alpha 1 by alpha 2 is equal to beta 1 by beta 2 is equal to k. This implies that p square by r square is equal to, from here we substitute the values p and r, we get alpha 1 plus alpha 2 whole square by beta 1 plus beta 2 whole square. We take alpha 1 common and beta 1 common, we get 1 plus k square by 1 plus k square, and then alpha 1 square beta 1 square is here, which we take common, and then 1 plus k square will get cancelled. So now this will be alpha 1 square by beta 1 square, and this will also be equal to alpha 1 alpha 2 by k. Okay, because if you multiply this, alpha 1 is equal to k alpha 2. So if you multiply both those, we will have alpha 1 square k. So we divide by k both sides. So we have alpha 1 alpha 2 by beta 1 beta 2 is equal to q by s. Question 436 says that if a, b, c are in HP and alpha beta be the roots of the equation x square plus bx plus c is equal to 0, then show that minus of 1 plus alpha beta is the harmonic mean of alpha and beta. So we are given that A, B, C are in harmonic progression. Now we look at the value of minus of 1 plus alpha beta, which is minus of A plus C by A. Now we look at harmonic mean of alpha beta, that is 2 alpha beta by alpha plus beta. Okay, that is the harmonic mean. Now we substitute alpha beta and alpha plus beta, we get minus 2C by A. But A, B, C are in HP, so what we can say is B is equal to 2AC by A plus C, which we substitute here, which becomes equal to minus of A plus C by A, which is nothing but minus of 1 plus alpha beta. Question 437 says that if alpha beta are roots of the equation, x plus 1 is equal to lambda x into 1 minus lambda x, and if lambda 1, lambda 2 are the two values of lambda determined by the equation, alpha by beta plus beta by alpha is equal to r minus 2. Show that lambda 1 square by lambda 2 square plus lambda 2 square by lambda 1 square plus 2 is equal to 4 into r plus 1 by r minus 1 whole square. So what we do is this given equation, which is x plus 1 is equal to lambda x into 1 minus lambda x, we write that and form a quadratic equation. So we get lambda square x square plus 1 minus lambda x plus 1 is equal to 0. Now it is given that alpha beta are the roots of this equation. So alpha plus beta is lambda minus 1, that is minus of this, divided by coefficient of x square, that is lambda square. And alpha beta is equal to C by A, that is 1 by lambda square. Now we are also given that alpha by beta plus beta by alpha is equal to r minus 2. So we put the values there and then we take LCM. We get alpha square plus beta square is equal to r minus 2 into alpha beta. That is alpha plus beta whole square is equal to r alpha beta. Now we substitute the value of alpha plus beta. We get lambda minus 1 whole square by lambda 2 power 4 is equal to r by lambda square. So from this, we can say that this will be another equation in lambda square, in lambda. So lambda square will cancel this, and then we will have lambda minus 1 whole square by lambda square is equal to r. So from this equation, we can say that lambda 1 plus lambda 2 is equal to 2 by 1 minus r, and lambda 1 lambda 2 is equal to 1 minus r. And then you take LCM over here and substitute the values, you will get this condition as true. Question 438 says that if the roots of the equation x square plus bx plus c is equal to 0 are reciprocal of those lx square plus mx plus n is equal to 0, then prove that a is to b is to c is equal to n is to m is to l, where a, b, c, l, m, n are all non-zero. So we let alpha beta to be the roots of x square plus bx plus c is equal to 0. Then we have alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Now for the next quadratic equation, the roots will be reciprocal. So 1 by alpha plus 1 by beta is equal to minus m by l, and 1 by alpha beta is equal to n by l. So from the product of roots, that is this and this, we can say that c by a is equal to l by n. And from the sum of roots, what will happen here is, if you take LCM, it will become alpha plus beta by alpha beta. That is minus of b by a by c by a. So a will get cancelled, it will become minus b by c. So b by c is equal to m by l. And from these, you can have this. That is a is to b is to c is equal to n is to m is to l. Now we solve question 439. If x1 and x2 be the roots of the equation, x square minus 3x plus a is equal to 0, and x3, x4 be those of equation x square minus 12x plus b is equal to 0, and x1, x2, x3, x4 be an increasing GP, find a and b. So we are given that x1, x2, x3, x4 are in increasing GP. So we let them as lm square, lm cube. That is, one of the roots is L, and then we have m as common ratio. So from the first equation, sum of the roots is L into L plus m. That is, L into 1 plus m. That is 3. And sum of roots for the second equation would be lm square into 1 plus m is equal to 12. So once we have that, we divide this. So we get m square is equal to 4. 1 plus m will get cancelled, L will get cancelled. So m square is equal to 4. 12 by 3 is 4. So m is equal to 2 because GP is increasing. It can't be minus 2. Once we have m is equal to 2, we substitute here and we get L is equal to 1. So from this, what will happen now is A is product of L into Lm, that is L square m, that is 2. And B will be product of last two roots, L square m to the power 5, that is 32. Now we come to the last problem of this set. Let P and Q be roots of, it's a typing mistake, roots of the equation x square minus 2x plus a is equal to 0. And let R and S be the roots of the equation x square minus 18x plus b is equal to 0. If P less than Q less than R less than S are in AP, find the values of A and B. So like previous problem, we will solve this. So from the first equation, that is from this equation, 440, yeah. So P plus Q will be 2 and PQ will be A. And for second equation, R plus S will be 18 and RS will be B. Now we let alpha to be the first term and D be the common difference. It's not really first term actually. Of the AP, yes, it is first term. So we can assume that P is equal to A minus 3D, Q is equal to A minus D, R is equal to A plus D, and S is equal to A plus D. That is how we assume for 4 terms in AP because we want to cancel out D. So we add this and this, we get, or rather P plus Q into R plus S. If you see this, then what will happen is P plus Q and R plus S will cancel out D. So you'll have 4A is equal to 20. So A will be 5. And then once we have A is equal to 5, we can say that D is equal to 2. Once, how can we say this? That we can take this product and solve that. So once we have A is equal to 5 and D is equal to 2, we get P is equal to minus 1, Q is equal to 3, R is equal to 7, S is equal to 11. Once we have that, we can see that A is equal to minus 3 and B is equal to 77. So with this, we come to the end of 44th set of problems. And now I will show you how to download this PDF. So the link will be in description, but I'll show you. So you can come to my website testouter.org and you can click this second link and download the PDF. The last update was on 27th of March, but note that if you look at the URL and then towards the left bottom of your screen, you see that the date is not part of the file name. So you can use this file name to see whether the PDF has been updated or not. And also you can download the trigonometry book from here, which is complete. There will be changes in these books, and when the changes will be there, the date will change. Okay, as of now, I'm working on the coordinate geometry and I will put the PDF here once straight lines and circles are complete. So I hope that you are enjoying this series of videos, useful and informative for your studies and exams. And I wish you all the luck for your career and your exams to come. So thanks a lot for watching the video. I'll see you in the next video. Enjoy.